Hi, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. Today, in this video lecture, let us see about clamper circuits. Clamper circuits are nothing but electronic circuits that shift the DC level of an AC signal. It is also known as DC voltage restorers or level shifters. Clampers are basically classified as positive and negative, that includes both biased and unbiased conditions individually. Those circuits are used to clamp an input signal to a different DC level. It basically adds DC component to the applied input signal in order to push the signal to either the positive or negative side. Clamper circuit is a combination of resistor along with the diode and capacitor. It sometimes also employs DC battery so as to have an additional shift in the signal level. Clamper circuits are constructed in a similar manner as that of clipper circuits. However, clamper includes an extra charging element, that is the capacitor, in its circuitry. The combination of resistor and capacitor in the clamper circuit is used to maintain different DC level at the output of the clamper. Now, let us see the operating principle of clamper circuits. The working of clamper circuits depends on the variation in the time constant of the capacitor. This variation is the outcome of changing the current path of the diode with the change in input signal polarity. Here, the magnitude of the time constant is tau is equal to RC. So this is chosen large enough in order to assure that the voltage across the capacitor does not discharge consequently at the non-conducting interval of the diode, but such a discharge takes place only when the load resistance is very large. This permits the capacitor to take larger discharge time. Conversely, a small value of the capacitor is chosen so that it will charge rapidly at the time of conduction of the diode. Now let us see classification of clamper circuits. The first one is the positive clamper circuit. The figure here shows the positive clamper. As we see here, the diode is in parallel connection with the load. So we can say reverse biasing of the diode will provide the output at the load. Initially, the positive half of the applied input voltage signal reverse biases the diode, but the capacitor is not still charged. So at this period of time, output will not be considered. For the negative half cycle of the AC signal, the capacitor now gets fully charged up to the peak in the AC signal, but with inverse polarity. So this negative half forward biases the diode, that results in the flow of the forward current through the diode. The next positive half then reverse biases the diode, due to which the signal will appear at the output. So at the beginning of the positive half of the AC signal, the diode is in the non-conducting state, that results in discharging of the capacitor charge. So at the output, we will have the summation of the voltage source across the capacitor and applied the AC input signal. So as shown in the output waveform, the signal level is shifted upwards or positive side. Hence, it is named as a positive clamper. Next one is negative clamper. So here, when positive half of the AC input is applied, the diode comes to forward bias condition, that results in the no load current at the output. However, a forward current flows through the diode that charges the capacitor to the peak of the AC signal, but again with inverse polarity. So the capacitor here is charged up to the forward biased condition of the diode. When negative half cycle of the AC signal is applied, the diode now becomes reverse biased. This allows load current to appear at the output of the circuit. So now this non-conducting state of the diode discharges the capacitor. So at the output, a summation of capacitor voltage along with the input voltage is achieved. So next one is positive clamper with biasing. So here we have two cases. First we will see positive biasing. So it is almost similar to the positive unbiased case, but here an additional voltage is provided, so has to have an additional shift in the level of the signal. When positive half of the input signal is applied, the diode is reverse biased due to the AC input but is forward biased due to the battery voltage. So until the voltage of the battery is greater than the input voltage, the diode will conduct. This forward current through the diode charges the capacitor but with the battery voltage. As the AC input surpasses the battery voltage, the diode will get reverse biased and hence the conduction through the diode will stop. When negative half of the input signal is applied, the diode is forward biased due to both AC and battery input voltages and it will start conducting. This charges the capacitor with voltage summation of AC input along with the battery voltage. Hence an output voltage level is achieved. Next one is negative biasing. So here when positive of the AC signal is applied, the diode will get reverse biased by both the AC and input and the battery voltage. So due to this, a current flows through the load and combinedly maintain the voltage level. When negative half is applied, the diode is forward biased due to the AC input but is reverse biased due to the battery voltage. So the diode conducts only with the AC input, dominates the battery voltage. This charges the capacitor, hence we get a shifted signal at the output. So next one is negative clamper. Here also we have both positive and negative biasing. So as we already discussed that a negative clipper shifts the signals downwards. Here in the case of positively biased negative clipper, the signal is somewhat raised to a positive level due to the positively applied battery voltage. When positive half cycle of the AC signal is applied, the diode is in the forward biased state due to the AC supply but is reverse biased because of the battery voltage. So the diode conducts when AC supply surpasses the battery voltage. When we apply negative half, the diode is reverse biased by the cause of the AC supply and the battery voltage. So this non-conducting state of the diode discharges the capacitor. Thus the voltage across the capacitor applies at the output. Next we will see the case of negative biasing in a negative clipper. So when positive half of the AC input is applied, the diode gets forward biased by the AC and the battery voltage. This starts conduction through the diode, resultantly charges the capacitor. At the time of the negative half, the diode gets reverse biased but will still conduct due to the forward biased condition applied by the battery. So the diode current flows until the battery voltage is more than the AC input voltage. The time when AC input surpasses the battery voltage, the diode gets reverse biased and the capacitor discharges. So thus the voltage across the capacitor applies at the load. So next we will see applications of clamper circuits. They are used to identify the polarity of the circuits. These circuits are used as voltage doublers and helps in eliminating distortions. Reverse recovery time can be improved using clampers. So hope you understood clampers. So we'll take up some assessment questions. So which of the following is not true regarding clampers? A positive clamper adds a positive DC voltage. A clamper can also be called as a reinserter. To reduce tilt reduces the RC value. Negative clamper will clamp the positive peak of the output to the reference voltage. Yes, the answer is to reduce tilt, reduce the RC value. A circuit with a predetermined DC level is added to the output voltage of the op amp is called as a clamper circuit. And clamper circuit is also referred to as a DC inverter. Thank you for watching this video.